intelligence and how it goes, how it impacts anything from social good to ambient intelligence. Let me start actually with a personal reflection, a recent experience I had in the mountains of Rwanda. I had the privilege to spend an hour with a family of gorillas in their natural habitat, and it was fascinating to see how they were interacting with each other. It's clearly they have their own language. And this actually, and by the way, they didn't pay much attention to my presence there, as you can see. But this reminded me of a gorilla, a famous gorilla called Coco. Coco actually learned to speak, learn language. And she learned over 1,000 words of vocabulary, and 1,000 signs, 2,000 words in spoken English. And it took her 46 years to learn it. And she became quite a celebrity, in fact, made the cover of National Geographic. But this also brings up this interesting question. In a way, many people would not even believe that a gorilla could learn how to speak before Coco. And the question is, what else can we teach about speaking? How about computers? Can we teach computers to speak? Can we have a conversation with computers? How far can we take artificial intelligence in that direction? And if we do that, what are the ramifications? And while gorillas already have their special language, in computers we actually need to teach it from scratch. So artificial intelligence is actually bringing some hope in that direction. But before actually going deeper into that, I'd like to talk about the other aspect of artificial intelligence. So first, obviously, we're seeing that in many products around our life. This is now one nice example that I like, which is we all have our phones taking pictures quite a bit. If I'd like to search for a photo out of my ever-growing gallery, today, sometime all I need to do is to just search. Just search for birds in sunset, and it could bring those pictures to me. These are actually from my own photo galleries, without ever labeling those. And in a way, I don't pay much attention to it, which is one of the magic of technology, is when we stop paying attention, when it just works. So this is really, we take it for granted, but it used to be magic, the fact that we can actually identify birds in sunset without ever labeling it, without training it. And this has really become possible by, obviously, advancements in machine learning and AI, more notably in deep learning, deep neural networks, and very simplistically, an image taken as an input to the deep neural network activates the pixels, activate those so-called neurons, which are essentially a computer program inspired by how we believe the brain functions, some of the brain functions work. And then those neurons' activities is propagating through the layers until at the end we have a classification whether it's a dog or a cat. And the way in which this network is built is by training it on many examples in a way similar to how we're training ourselves to recognize a new object. So obviously this made huge strides over the last decade, and this technology is now, I'm sure you heard it many times recently. But the beauty about this technology is that while it can be used for many fun stuff, such as searching images in our photo album, it can also solve some pretty serious problems. And again, such inspiring example is what it can do in health. And again, many of you heard about diabetic retinopathy. This is a condition that may affect people with diabetics. Actually, if not treated, it can lead to loss of vision, loss of sight, to blindness sometimes. And the good news is that you can diagnose it by inspecting, doctors can diagnose it by inspecting an image of the retina. The bad news is that there's a huge shortage of eye doctors, which put at risk millions of people worldwide to lose their sight. And the inspiring example here is that a research done a few years ago where one could train machine learning models to have diagnosis which is in par with what experts can do and therefore complement that. And by doing that, now all you need to do is to bring a person to a scanning device, to take a picture, have the system help out with diagnosis, and then save the eyesight of that person. This is actually an image taken from a clinic in India where there's already a pilot going on. So what has started as a research became a realization, is now actually already deployed in places such as India and Thailand. which is very inspiring to us. What other problems can we solve? And indeed, some of you may have heard last year about a follow-up research of looking into the retina. And what started out as an exploration, what can we learn from an image of the retina, perhaps? Can we identify some other characteristics of a person just by looking at the image? Turned out to actually have discovery that of phenomena that we did not even know about. The fact that the research published showed that you can identify some cardiac signals and risks based just on the image of retina, a fact that was not known to the medical community before, which is a great example of how technology can help us not only solve known problems or provide solutions to known methods that we want to solve, but also give us new insights that we were not even aware of. So this is obviously bringing up more hope, and indeed, just recently we just announced this research showing how we can train machine learning models with the right methodology to help out with scanning to have an earlier detection for lung cancer, which is one of the deadliest diseases out there. And again, think about all the impact that we would have with this technology. So these are all very exciting progress that we see worldwide, and I'm really excited about the possibilities for health. But when we think about the impact of AI to our world, it's not only to health, which is hugely important. There are many other societal problems that we can actually address with AI. And one such area that I'd like to actually spend a few minutes about is crisis response. And crises are situations where people find themselves in danger. And once somebody is in crisis, they have a very strong need for help, for information, for technology. So to reflect on that, I'm going back to my own personal experience 8.5 years ago. This was in December 2010. I have a team in Israel. I'm in Tel Aviv and Haifa, and that day I was in our Haifa office, and we had one of the deadliest fires in the Carmel Mountains, which is not too far from the office. So this picture was taken by my camera. Actually, I checked the metadata on the picture. It's by Google Nexus 1 phone. And at that point, it was clear there's something going on, but searching for information on the internet, they revealed very little information. And I was really eager to ask questions such as, what should I be doing? Should I evacuate the office? Should I alert people to leave their homes or something? And there was no information available on the internet. It wasn't until I called the mayor's office, I got a number with some actionable information, and actually asking my search team to put this information online. As a result, for anybody searching for the same stuff that I was searching, this was actually one of our early launches of actionable information crisis response. And later on, we used it for dozens of other such situations. And we had a lot of investment in crisis over the years, but a couple of years ago, and I should mention that I was not alone in doing this. So what we see is that whenever there's a crisis, people are turning to Google to search for information. You can see that during floods, during hurricanes, during explosions, they're looking for information, not only because they'd like to learn about what's going on, but because they'd like to take action. They'd like to know what they should be doing about it. So to that end, we actually built a team, and we launched a couple of years ago a product within Search called SOS Alerts, where every time there's a big crisis, we're trying to pull together and provide the best information that we can, so as to help people about questions such as what's going on, where is it, what should I be doing, how can I help? And since then, unfortunately, there were no lack of crisis out there. There were over 250 activations worldwide, with and tens of thousands alerts, which are public alerts coming from various governmental agencies directly into people's phones, with a total of over 2 billion views on those crises, which in many cases we are hearing about how helpful it is. However, we also learned in the process there's certain crises that we cannot provide a lot of help. And in fact, one of the most devastating natural disasters is our floods. Floods are affecting up to 230 million people per year globally. They are actually believed to be responsible for over 6,000 fatalities per year globally. And some of those can be perhaps avoided if people would have enough information, which typically we just don't have it. And we see those examples, in fact, when you do have information about floods, then people can take action. So for example, this is a testimonial of in places that we did have information about floods and people could take action. And just last week, we saw an example, actually a very beautiful example about how the Indian government and Bangladesh took action during the cyclone Fani. And because there was a pretty good prediction about where the cyclone is going to be heading, they could take action, and based on preparation for many years and a great execution, they actually managed to mobilize many people and get them out of danger zone. But then many other floods where actually this is not happening. Reason being that, for example, whenever there's a monsoon season, rivers are starting to rise, and quite often we know that there's going to be flood somewhere, but we're not sure exactly where. And the difference between knowing just generally versus knowing exactly makes all the difference in the world. So what we can see here is the situation where the accuracy is not good. You know that a flood is may be going there, but if you don't know exactly where it's going to happen, people are not going to take action, as we learn, and governments cannot take action because there's too much area to cover, so it's just not practical. So the question is, can we get this higher accuracy prediction? And as I'm going to discuss, indeed this is turns out to be possible. However, 2 years ago, if you'd asked me if it's possible to provide this kind of flood forecasting, I would say I don't know, because there's a lot going on into this computation of predictions of flood. So after some exploration, we managed to figure out that actually we could do something about it. And we did have some progress on flood forecasting. So the way we're treating it is by first taking very accurate data elevation models of the terrain of the places that we're trying to predict. And this alone is a very interesting and important computational problem based on taking aerial imagery, using machine learning to reconstruct the terrain, and then using machine learning to recalibrate what's going on there based on historical data. Once we do that, we can run thousands, sometimes hundreds of thousands of simulations using physical models, hydraulic models, where we try to anticipate where the water is going to go. And in order to do that, we need to have some readings of the water so that we can base our computations on. And we have here a partnership with the Indian government to get exactly this data. And of course, all that needs to be done per place because the soil may be different. We need to match it versus past experience. So there's a lot going on in order to do that. And getting into this effort, it wasn't clear whether this is feasible or not. It turns out that it is. And indeed, just last year, we announced a pilot in Patna, this bluish area that you see here, where we had the accuracy of 90% prediction a few hours before the flood themselves, which was very encouraging. So we doubled up on that, and we just announced, and we already had an activation back in September where we could actually send out to people's phone exactly with 90% accuracy the area where the flood is going to occur. So based on that, we doubled up, and now we are expanding, and we expect our effort to go and cover order of magnitude into much of the rivers in India, and save many, help out many more millions of people, and then also work on disseminating the information so people could just get notifications on the phone, which will drive them into the alert about what's going on, and they could even go to map to go deeper and navigate themselves. So this is very encouraging to see how exploration of something that we don't even know possible turned out to be something that is feasible, and we're very excited about the collaboration also with the government. But I'd like to also point out another instance of how AI can be used by everybody. And this is another very inspiring example. These are two high school students, Sanjana and Aditya, who actually took TensorFlow, machine learning models from TensorFlow, and they built up small devices using some parts they put themselves, and they put them in various areas of the forest in California to learn, and they train the models to identify when there's a risk of fire because of dead wood and other parameters. And by being able to alert about the risk, they could actually send notification to CAL FIRE so they can prioritize going and check these areas and hopefully prevent some fires. And the fact that you can have two high schoolers take off the shelf, take libraries, and just use them and solve an important problem, I think is a great opportunity that we have today, and it's just increasing. So if we think about these two examples, these are good illustrations of why we started the Google and the AI for Social Good program, where we're looking more closely into how to first double up or focus on our research and engineering around these societal problems. And on the other hand, how we work with building an ecosystem and supporting the ecosystem with the realization that Google cannot solve all problems, obviously. And in many cases, actually, we're not even aware of the problems that could be solved. So the opportunity for everybody to actually pitch in and identify problems and bring their own expertise, I think, is a great opportunity that we have. And we just announced the 20, along with the program, we announced the Impact Challenge, where we asked everybody to come and submit a grant and apply for the, for grants and support. And we just announced the 20 winners for that, which are coming from all over the world and are also touching many areas, agriculture and emergency services. And some of them are about societal issues. Some of them are about suicide prevention. So we see a lot of variety. But also it was great to see we had over 2,600 applications from 119 countries, and 40% of them without any background in machine learning. So the hope is that for many of them, perhaps getting some mentorship and exposure is going to actually help them even accelerate some of their developments in areas where machine learning can actually help. And indeed, in addition to the monetary funds, we're going to kick off support by a program that we have called Launchpad, which is about mentorship of startups. So the notion of working with the community is not new. In fact, we have a Launchpad program that has been running now for a few years, and we're focusing now on Launchpad Accelerator that provides mentorship on machine learning and AI to startups all over the world. We had over 200 startups going through that program, and thousands of startups going through mentorship in general by Launchpad. And Launchpad is a global program. In fact, it started in our site, in our office in Israel, experimentally, and since then it's been running in Israel, in Africa, in many other countries. And by the way, talking about Africa, it's great to see talent going everywhere and how to encourage that. So I was really inspired visiting there last year when we inaugurated a program called the African Master for Machine Intelligence, and getting to talk with some of the students who are representing the next generation leaders. And again, this is a kind of a reinforcement. And whenever I go everywhere in the world, you can see that really the talent, the entrepreneurship, the opportunity is everywhere, which is really exciting. Let me also point out that when we think about collaboration in community, it's not only big companies and startups and NGOs. Sometimes there's an opportunity to do even broader collaboration. So I'll just highlight this collaboration that we're having with the World Bank and the United Nations and additional tech companies to try and address the problem of famine. So it turns out that even today, famine is a big problem worldwide. It can impact millions of people. And one of the single most important item to help these people is to identify famine early enough. Not wait X months after it happened to then take action. So we have collaboration where we're trying to help out on developing with the machine learning models that can identify the indicators of food insecurity and thereby enable the World Bank and other organizations to take actions earlier to divert resources before it becomes a real crisis. So the opportunity to have collaboration on a large scale and global scale by everybody for social good and incorporating AI to do that, I think is pretty significant. Now, with that, I'd like to actually switch gear and talk about, one last note about it is that even on floods where we're focusing a lot and we have a sizable team, even here we understand that we can only talk about a small subset of the problem. And there are many problems around floods that we don't necessarily have the expertise. So just recently we brought together some 80 researchers and people from working for governments and other organizations to discuss how we could bring together expertise in hydrology, in physics, and machine learning, and have this conversation to see how we can actually together tackle these problems and get some more progress on that. And with that, I'd like to switch. So if AI here is about how to solve societal problems and really impact people's lives, sometimes saves their lives, serves their site, make them safe, there's another domain where I find that AI is becoming increasingly more significant in our lives. And I'd like to talk about conversational AI, about how we can have conversations among ourselves. So going back to the questions raised by Visit to Gorilla. So many of us grew up on the aspirational, magical experience of Star Trek. Could we ever speak with a computer in a natural way like we do with a person? Just ask questions, get answers, get advice. We don't need to learn new methodology. We have the interface. That's what we do. And in fact, this goes back even to Alan Turing, founder of computer science. He was already asking the question about, can people talk to computers much in the same way that they talk to each other, famously known as the Turing test. Now, just think about it. If we could have this conversation, obviously this opens up, it makes it accessible to many more people, because all you need is to ask the question or to ask for something to get done. So this is obviously a big problem, but we've seen some progress in the last years, in recent years, and many of them actually we don't pay much attention. So today, many of us already, when they want to search for information, they would just ask their phones. Many would just talk to their assistant or the phone to set up an alarm, and it should just work, right? There are hundreds or thousands of different ways in which you'd like to set your alarm, and you expect it to just work. And of course, there are many other situations in which we'd like to use conversational technology. And the reason why we're making this progress, of course, is by having speech recognition, which is becoming better and better, and the ability for speech synthesis to take text and to read it back to a user. And there are additional ingredients of a conversation that we have had some progress on. So for example, smart reply, whereas we have a question, we can get a guess about what the answer may be just based on experience, which is actually sometimes surprising. Some people are offended by the fact that they are a little predictable. Smart compose is another example. In fact, this technology at some point were some I believe some April Fool's joke by some folks, and today they're just working, right? And it's pretty magical when it does. These are two ingredients, but I'm very excited about also the technology that we can actually speak a text, the text-to-speech synthesis, which became very natural. So, for example, could we just listen to pages? So, in fact, we launched last year, and we have a version of Google application that works for in India and Brazil and other places where sometimes you have lower-end phones or internet connection which is constrained. It's called Google Go, and we launched with it the ability to just read whenever you see in the browser a web page, should just listen to it.
Up to 15% of slots from the new runway would be dedicated to improving domestic connections, and the government hoped that the increased competition with existing routes would give greater choice to passengers.
So this is an example that you can just listen to the page in your Google Go application. And the beauty here, this is also highlights the words. So obviously it's for convenience, but for many people it turns out it's quite important because of literacy. If they find it difficult to read the text, either because of literacy issue or because it's a foreign language to them. And we just announced using the same technology to solve related problems, such as what if you see text, you're on the go, you're in the street, you'd like to understand what's going on. Today all you need with again, Lens Go is to point out your camera to that, your telephone to that, and to hear what's...
Information for card holders. All customers using old proprietary magnetic stripe cards should be advised.
And the beauty about technology is that now we can start to put them together and connect them in various shapes and various forms. So for example, Translate is a technology that used to be science fiction, but today we just expect it to work, right? You open a web page, it's in a different language, you hit Translate and you see it, and it's pretty good. It still have room for improvement, but you get a sense of it. So what if we just bring them together?
Información para los titulares de la tarjeta.
Just by putting them together, suddenly we reduce barrier. Suddenly a person that could otherwise not read a sign for some reason can now hear what's going on there. Now, another inspiring project was developed by Dimitri and Chen. So this is about, Dimitri is deaf, and he worked on taking the speech recognition technology and making it to work in what we call live transcribe. So you can just listen to the conversation and seeing it on your phone, and this has been now going on for some time. But when you think about these technologies of speech recognition, text-to-speech, there's more that we can do. So if you cannot hear today, we can just click on the button and get those live captions, which we just announced. And think about people who cannot hear. Now, everything that your phone is talking becomes available for them.
You like the blueberries? Yeah. Blueberries? Delicious? Comes more. Should they act?
So you can apply it for anything that your phone, essentially anything that your phone would sound to you. And if you think about it, for some people, it's actually making the difference between understanding what's going on and what not. For many, or for all of us, it's really about when you get into situations that you just don't want to hear the sound, or you just want to also read it. Now, the way I'm thinking about it is that this is really reimagining what the mute button is. Mute is not about I don't want to know what's being said, it's about I don't want any noise to be made. So you can actually just cross modality. You can just move the hearing from a modality of audio to a modality of screen. And if you think about removing barriers and the fact that with technology today, we can just move the conversation in a fluent way between modalities, or have them in both modalities, from audio to text, from text to audio, the opportunities are plenty. And we have more examples, right? So now going back to Dimitri, he can hear what other people are saying because we have voice recognition that works pretty well for those who are talking with common accents and common pronunciation. But when he's speaking, because he has a heavy accent and he became deaf at a young age, our speech recognition devices actually don't really understand him very well, and you've seen it before.
Google has very good general speech recognition, but if you do not sound as most of people, it will not understand you.
So the premise of just talk to your phone and get stuff done doesn't quite work for him. And this doesn't quite fit our commitment to make Google work for everyone and to make technology work for everyone. So we embarked on this project, Euphonia, which actually was starting out by asking ourselves, can we help ALS patients whose speech deteriorates to be understood? And we trained and we built up technology that can actually take personalized training of models for speech recognition. And Dimitri actually took these models, he worked with our engineers, and he's put a lot of time to train on thousands of sentences, and the result was actually quite not what we expected. The error rate that he's getting is actually in par with what we're getting on a regular speech recognition. Of course, this is still in research stage, and we need to find ways not to rely on those thousands of training. But here's the example of what we get today.
We need to make all voice interactive devices be able to understand any person who speaks to them.
So this is pretty transformative, of course, and again, we are getting some very positive feedback from ALS patients we're working with about the ability for them to express themselves in a way that now it can be understood. So I'm really excited about this technology. And again, as it goes with accessibility, interestingly enough, quite often when you develop for the hard cases, it turns out that you can make progress for many more cases that you think about. So for example, we just actually, the teams wrote a research paper which showed that the same technology that is used for those extreme cases can have a tremendous improvement over known data sets for, with accents. And the way this works is essentially applying, building up models of machine, training data sets based on visual spectrograms, then training them, and we need plenty of them in order to really build it in a personalized way. So these are the different kind of fingerprints, if you will, of the various spectrograms that are here. So these are all good, and when we talk with our phone and with our assistants, this is kind of the problems that we're typically facing. But I actually want to go a little bit back to an older technology, the phone, and I appreciate that some of you perhaps are not familiar with this device. So this is a phone as it used to be at some point in the past. So it turns out that even though much of our activities with our assistant, with our phones, there are plenty of cases that people still need to pick up the phone to make a conversation. And for example, it turns out that even though you'd expect that a lot of what we do today is just online reservation, etc., 60% of businesses in the US that are relying on reservation do not have an online reservation set up. And if you really want to talk to them or to do something with them, you need to pick up the phone. And pick up the phone is, so we need to take care of that. And picking up the phone sometimes is irritating, and for some it's impossible, either because of circumstances or because of accessibility of other reasons. So to that end, we announced last year Duplex, which enables one to have a phone call made on their behalf by the assistant to make phone reservations and to do it in a pretty natural way. And indeed, today this is already working in the 44 states in the US, and we get some great feedback from users and from businesses. And what enabled Duplex to do the job is really a combination of many technologies. And they have to do with analysis of the audio source and the speech recognition and the text-to-speech. And of course, using deep neural networks that are built for that, because we need to understand also the intent of the conversation. And all that is possible because we focused on very specific domains, so we could actually build those models in a way that work sufficiently high quality to do that, along with a lot of machinery around it, such as real-time supervised trainings and more. And of course, we also added to that, since our aspiration was to have a very natural conversation, then we added those, what we call speech disfluencies, which are part of the communication, they are part of the conversation. They are actually part of how we communicate. It's part of how we are saying no in a soft way, in a polite way. It's how we acknowledge while waiting for the other side to actually talk to us, actually field in linguistics called pragmatic, which looks into some of these speech disfluencies. And this putting all together enables us to have a conversation that is natural and can achieve this goal. So there are many other natural ways in which natural conversation could help us. And I really encourage everybody to think and to apply their imagination about what can be done. In fact, some time ago, I was having a conversation with my wife about conversational AI. So she actually pointed out to me an opportunity. She actually challenged me, well, if you can do conversational AI, why couldn't you solve this problem for me? And then she pointed out that every time her phone calls and there's an unknown number, she has a dilemma. Well, perhaps it's a sick child or a sick parent, but if she would answer the phone, then it's likely going to be somebody trying to sell her on a cruise or new insurance, which is pretty annoying, and I'm sure we all experience that. So could we use conversational AI to help with that? Could we use it to actually take some of the burden from us, give us back our control over our time, over our attention, etc.? So indeed, fast forward, we announced just a few months ago a feature called Call Screen. And Call Screen is utilizing conversational AI in a basic way to really answer the phone on your behalf, if you'd like to, on unknown numbers, and to help you figure out who's calling by asking the other side and then showing you the result in real time by transcribing it to you, and then enabling you to actually ask some additional questions and eventually pick up the phone or decline or just or report spam. And really, this is facilitated by a combination of all these technologies of speech recognition, of text-to-speech synthesis, and everything runs on device. So it can be offline, it's totally private, and the fact that it can run on device is really one of the significant advancements that we've seen, and you heard about it as well. The fact that we can actually do things which is instant, isolated, it's yours, and it doesn't actually leave your device. So obviously this is a highly popular feature because everybody can relate to. It was actually interesting to hear from people not only how happy they are for not being, never need to speak with the telemarketing again, but we also heard from a few people that because of that, they actually took a call that they would otherwise ignore that turned out to be a hugely important call. So think about it as a way to help get control over our time, of our attention, and of course this can go a long way as well. So one direction in which this can go is actually, again, coming from an engineer on my team who came to me one day and said, hey, my heart is really with accessibility, and I'd like to take close screen and extend it so that people who are deaf could have a full form conversation by adding additional technologies. And here, in order to do that, you need to be synchronous, you need to be able to type in real time, but then we could use all those features that we mentioned earlier, Smart Compose, Smart Reply, and indeed, so this is still kind of in research stage, but this is an example.
Hi, this is Nicole's assistive chat. She'll see what you say, and her responses will be read back to you, starting now.
Hi, Nicole, it's Jamie. How are you?
Hey, Jamie. I'm good, and you?
Great. Are we still on for your 1 p.m. haircut tomorrow?
Sorry, can you do 3 p.m.?
Yes, I can do 3 p.m. We have a lot to catch up on. I want to hear all about your trip.
Perfect, thumbs up.
Great, see you tomorrow. Bye.
So think about everything that comes together in order to facilitate it. Speech recognition, text-to-speech, guessing how to type, helping it out. But think about the ramification of that. It means that essentially a person could have a regular phone conversation on the one hand, the other person doesn't need to talk or hear, perhaps because they cannot talk or hear, perhaps it's not convenient to them, perhaps it's a new generation that doesn't like to talk on the phone, they're just used to chatting. This is cross-modality. Perhaps you're in a meeting or on a flight and you'd like to take a phone call over some other ways. And think about if we would integrate in the future, say, translation, the opportunity to actually have a conversation with somebody in a different language. Totally seamless, totally ambient. In a way that actually we don't pay attention, just reducing barriers, it just lets people to communicate in a better way. So these are pretty exciting opportunities, I think. I think these are examples where we're solving a problem sometime for one person, or because we're excited about it, and then it turns out to solve a bigger problem. But in many of these examples, to reflect on them, many of them were actually situations that we not necessarily anticipated. They came out from a single passion, or from exploration, or in the case of flood forecasting, we didn't know that it's solvable. Actually, even when starting call screen and live relay, it wasn't clear that we can actually put the technologies all together to get to the right level. Until we start, we don't even know that we do that. And I was reminded of that actually in a recent vacation in Spain, when having a morning run and at some point deciding kind of spontaneously to take a detour, and found these amazing kind of bays and landscapes that otherwise I would miss. So I think that research and technology have this nature that quite often we need to have this exploration and we need to try, and that's some of the magic of what's happening on those. Now, reflecting on where we are with conversational AI, I think we're in very exciting times. Think about all the technologies and everything that could happen if we have all these technologies get to much even better accuracy in a way that we don't even pay attention to them. Think about the barriers that can be reduced. The fact that every person can ask a question, can get stuff done in a seamless way, in an ambient way. The magic is that when a technology just works, it becomes totally ambient. That's what I like to think about as ambient intelligence. And another reflection is, if we think back, today we're having all these technologies and all these products that a few years ago were kind of just aspirational. We didn't even know if we can actually solve them. We didn't know that actually today we could have these conversations and hear back and have all this stuff just working for us. Which interestingly, if you think about the future, what is going to entail? So it's very difficult to predict, but I think that it's pretty, one can expect that even though I don't think we're going to see anytime soon a beam me up Scotty kind of technology, for many other technologies, if you can dream them, you can probably build them. Thank you very much.